Alright, now it's time to install the drives. So we'll start with the hard drive. And the one we're going to be using here, since we're building the mid-level system up here, is a little bit more expensive than your typical drive. The main thing that makes it a little more expensive and a little better is the fact that this is 7,200 RPM, so it spins faster, which means more data can go by the heads and come streaming off the drive faster than other drives. Also, this has got what is called an ATA 100 interface, which also helps in moving the data off the drive quickly. And it's a very large drive, 45 gigabytes. So that's pretty good size. Now, in the economy system, we'll put in a more ordinary drive that would cost basically about half to maybe one-third the price, maybe 10 gigabytes, regular 5,400 RPM drive. And they're still pretty good, but they cost not nearly as much. So this would be especially useful for people who need to move massive amounts of data, like this system is going to be used in the video production system, and so there will be need to have lots of large files and have to move them very fast, and so this would be a perfect drive for that purpose. Now, one of the things we're going to look at first is actually something that most people don't even think about, and that is what kind of screws go in this drive. And strangely enough, we actually have two kinds of screws. The ones on the right here are more of a coarse thread, and they're always used in hard drives. And the ones on the other side, on the left side, these have more of a fine thread. And these are used in the CD-ROM drives and the floppy drives. It's a little bit hard to tell apart unless you look very, very closely at them, but they will strip out the holes if you put them in the wrong way. And we'll go ahead and get those mounted right now. Now, this is the chassis that came out as a unit from the mid-tower unit. And this one's pretty easy to put in. The hard drive is pretty easy to put in. We're going to put it in the lower level. And if you look in the front, we could have actually 3 drives coming out the front, but these are going to be blocked off. We're only going to have 1 drive coming out the front. And we're just going to put the hard drive in the bottom. So we have to get the screw holes lined up, find out where they line up. Okay, right about there. Let's get that held in place. And I am wearing a wrist strap, so even though I'm touching electronics board, there's no chance of causing any static. Now on the floppy drive, get that out too. We're going to have to make sure that this comes out the right distance to the front, so it's going to match up with the front cover. I've already checked this, but this is a trial and error sort of thing because we have several holes here, and this could be arranged in different ways for different cases. But I've already tried this out, and we're going to have to, we'll just put in 1 screw first. Put in the front one here, so we get one of them in. And the one for the economy system will go in the same way. It's just a slightly different kind of tray that slides in. And there are some systems that do not have trays. We'd actually have to put these drives in individually in the racks, but most of them are like this these days, so that makes it a lot nicer. Okay, now we're going to talk about the cabling. The cabling going into the drives, first of all, if you look at the back of the drive, you see some documentation here. Usually, every drive has some documentation to indicate which type or which position the drive is going to be. On each of the cables that these IDE drives use, there's going to be 2 connectors for the drives. One is for the master drive and the other one's for the slave drive. We can't have 2 masters on one cable because they'll conflict with one another, so we always have to have one be the master of the other. And that is accomplished through these jumpers right down here. It's a series of jumpers. I can't tell you exactly how these jumpers are arranged because every drive is different. Every manufacturer will set up their jumpers differently. Fortunately, this is an IBM drive which they've documented everything, every possible combination along the back here. Western Digital does the same, Maxtor does the same, but they're in different patterns, different ways. So you'll have to pay attention to the documentation, for your particular drive. This one has a lot of different combinations because it's such a big drive. This is a 45 gigabyte drive, and there are some problems. Some older systems can only recognize up to 32 gigabyte drives. And so there's some settings here that would make this drive look like a 32 gigabyte drive so those systems could use it. Of course, that's not really what you want to do. It would be a better idea to update your system so it could recognize the full size of the drive. Anyway, so you may have to make sure those jumpers are set correctly. They always come from the factory with the master set, or they usually come that way. So you just want to double check this settings here, compare it to the documentation, and make absolutely sure it's set for the master. You always have to have one master per cable, and since this is the only drive we're going to have here, it has to be the master. The second thing is, how do you hook up the cable? Well, first of all, you may notice that there's a stripe on one end of the cable here, and that indicates pin 1. There's 40 pins here, so this would be pin 1, and this would be pin 40 on the other side. And then you want to make sure you know where pin 1 is on the connector. And on the drives, on IDE hard drives, it's pretty easy because pin 1 is always going to be near the power connector. There were some older IDE drives, we're talking maybe 10 years old, that did not always follow that rule, but all the ones made today follow that rule. So if we take the stripe and we make sure it hooks up to the end that has pin 1, that is near the power connector, we know that's pin 1, so this end is hooked up correctly. Okay, so we got the cable on here. One other thing about the cable. This is a 40-pin cable, and you can probably see that there's, well, probably not going to count them all, but there's 40 pins there, 40 wires to go to the 40 pins, and that's a standard IDE cable. Incidentally, it's also called ATA, stands for AT attachment, IDE, integrated drive electronics. They mean the same thing. Different people use different terms, but they really are the same. However, we do have a newer cable for the newer drives that looks like this. Get the pin 1 going the right way. If you take a look at the difference between the two, you might be able to tell, it's very hard to tell actually, but these are much finer. And if you actually took the time to count them, you'd discover that where this has 40 wires, this has 80 wires. Now it still is going to plug into the same connection, so I'll take this off here. It still plugs in, so obviously there's only 40 pins. So why does this have 80 wires? Well, the answer is the extra 40 wires here that don't actually hook up to the pins are used as a kind of shield. And that is going to allow it to work in faster drives. The drives come out in different standards, as I already mentioned. ATA 33, ATA 66, and ATA 100. The 33 came out quite a few years ago. The 66 and 100s came out just in the most recent years. And what that is relating to is the speed of the drive. How many megabytes per second can be transferred across this cable? 33 is 33 megabytes per second, 66 is 66 megabytes, and so on. These cables are a real good idea for any situation because they do cut down on electrical interference. That's what the shielding does. But they're absolutely required for ATA 66 and ATA 100. Since this is an ATA 100 drive, we're going to have this cable on there. The other cable just wouldn't work. It might work, it might seem to work, but there would be much greater chance of errors as it's transferring its data at such a high rate. So that's why we use this special cable. Now the floppy drive has a different kind of cable. Floppy drives, of course, run a lot slower, so we're not going to have to worry about high-speed transfers or anything. And this cable doesn't look quite the same. It has only 34 pins for one thing, but also the stripe in it is a lot harder to see. Oh, incidentally, the stripes on these could be any color. Both of these happen to be red, but they could be blue or black or brown, just some color other than the rest of the cable. In any event, even on the floppy drive, that's going to indicate pin 1. But unlike the hard drives, the floppy drive pin 1 on the drive itself is not necessarily near the power connector. That's what this is right here. As a matter of fact, on this one, if you look real closely, at the top of the circuit board right here, let me tilt that up a little bit, right there is the number 2. Now, there's always going to be a pin 1 and 2 at one end and a 33 and 34 at the other end. And so if you see a 2 written there or a 1, either one, that's the pin 1 corner. And as you can see on this one, it is not near the power connector. So a lot of people will plug this one in backwards. We're not going to do that. Let me get the other end here. We're going to plug this in, find the stripe here, that's pin 1. It's written in there as a 2, pin 1 and 2 at that end. So we're going to match those up. And if we can get it, let's try it again. There we go. Get that plugged in there just like that. And that will be pin 1. Now we have to make sure that pin 1 at the other end on the motherboard is connected correctly too, but we're not quite ready for that. The floppy cable, you may have noticed this, has a weird looking deal here. It's like this cable is broken. It's not broken, but what they've done is, this is done on purpose. It's a twist in the cable, and what the twist will do is that any drive hooked up to the connector after the twist is going to be the A drive, and anything hooked up in the connector before the twist is going to be the B drive. Now the full reasoning behind that, why that's the case and how that works, is given in the book, but just when you're assembling this, just remember you want to put the A drive after the twist. The B drive is before the twist. Remember it that way, and it's real easy. Okay, we're all set to put it in now. Let's get these cables through here. This one is the one that mounts through the front. Now in the economy model, this would be a little bit easier, just mount from the back. Either way, it's a lot nicer than it used to be. Now this isn't too bad, but it does move around a little bit. There is a screw that will go in there. In fact, might as well put it in right now. And now that's totally secure. Okay. Now, of course, we've got the signal cables for moving the data, but we need to hook up the power as well. The power cables we have several power cables, not only going to the motherboard, but to the drives. We have 2 strings here, and it doesn't matter which one you use. They all have the same power supplies coming on all of them. The only difference is going to be that we do have 2 different sizes of power connectors. This one will be for the floppy, the smaller one, and the bigger one will be for hard drives and CD-ROM drives. So let's hook up the hard drive first. Now, as you also might notice, if you look at it carefully, point this out to you, on the bottom side here we have a couple of square corners, and on the top side we have a couple of kind of rounded corners. And the theory behind this is that you can't pound a square peg into a round hole. So there's no way you can put it in backwards. Well, let me tell you, some people have done it. So if you find that it is going in rather difficultly, then you know, or you might, have it in backwards. But there are, when we put it in the connector here, there are going to be a couple of square corners here. And when we put it in, the square corners should match, and the rounded corners should match. And it does go in rather firmly, but that's the way that goes in. Now the floppy is going to be a lot easier to get backwards. This is not a very good design. If you can see how this goes in, those 4 holes just match up with those 4 pins. And it can be pretty easy to either get it in backwards or maybe just to get it off by 1 pin, like that. So you need to make sure that all 4 pins get in just right. Unlike the ribbon cable, where if you plugged it in backwards, probably nothing is going to go wrong, if you plug this power connector in backwards, it's going to smoke the drive. The drive will die. So you want to make absolutely sure you get the power connectors in correctly. In the motherboard we have a series of connectors. Now this is a special motherboard that has 2 extra connectors that most do not. I'm going to start with the standard connectors that virtually all motherboards have today, and we'll start with the floppy connector right here, and that's a 34-pin connector to match the 34-pin cable. Then right next to it we have 2 IDE connectors, and that can be used for either hard drives or CD-ROM drives, anything that follows the IDE or ATA, if you want to call it that, standard. What's most important here is that we find out where pin 1 is actually located, and on this one usually there's going to be some kind of notch or a number 1 or a dot or something like that near one of the corners. And I believe the number 1 corner is right up there and right here. It's actually just a solid line. It's very hard to see, but we have a thin line going along here, and right on that corner it's more of a solid line. Actually, it's an excellent example of how difficult it is to find pin 1. Some of the other ones are a lot easier because you have the number 1 just written right in there, or a big dot, or an asterisk, or an arrow, or something like that. But this one's not quite so obvious. But this is pin 1 right here. Now, if it isn't pin 1, if I think I've got pin 1, and I don't really, and I plug it in backwards, I'll know immediately, as soon as I turn the computer on, the floppy drive light will come on right away, and it will stay on, and that's my signal I've got something in wrong. So I'm going to be paying very close attention to that. Okay, it's time to plug those in. So we'll get the floppy cable in first, because it's nearest. So we'll just get that plugged in. And then we'll plug in the hard drive. Actually, we're going to do something different with this hard drive because this particular motherboard has the special ATA100 interface on 2 special connectors. So this one is a little unusual. Every cable can have 2 drives, so we can normally have 4 drives, 2 on this one and then 2 on this one. This particular motherboard design has the ATA100 interfaces added to it, so we have 4 more drives. So we can actually have a total of 8 ATA drives in this system. And so I'm going to use one of those faster ones because I got a faster drive. So I might as well make use of it. So now that we have our drives installed, the next step would be to make sure that they're working. So what we would need to do is have an emergency boot disk. The instructions on how to build your own emergency boot disk are given in the book, so you can read through that section. And first we start by booting to the floppy and make sure that works. And once that happens, then we need to enable the hard drive, identify the hard drive, that's also given in the book. And then finally we would load whatever operating system we choose. So that would be up to you whether you want to use Linux or Windows or any other operating system. That would be more in the area of software. But for now, we've got the hardware done for the essentials.